when money's involved, you really want to have the safety net of tests, don't you? I've had lots of situations, never that's impacted billing, but lots of situations where I'm so supremely confident in a little tweak I just make, and then I just push it, then break something. And it's always a big surprise. And that's the thing I like about testing is it stops you being surprised so often. But I've been kind of obsessed with testing for ages. So if anything, I've gone the other way of over-testing, and I'm sure we'll talk a bit about that.
Big thanks to our partners Linode, Fastly, and LaunchDarkly. We love Linode. They keep it fast and simple. Check them out at linode.com/changelog. Our bandwidth is provided by Fastly. Learn more at fastly.com and get your feature flags powered by LaunchDarkly. Get a demo at launchdarkly.com. What's up, Gophers? Our friends over at Gravitational made a big transition at the end of 2020 to rebrand as Teleport and shared a new product announcement to showcase the direction they're taking. Teleport is operating from a vision of being able to run and access software anywhere in a secure and compliant manner, something they call environment-free computing. With Teleport, engineering teams can quickly access any resource anywhere using a unified access plane that consolidates access controls and auditing across all environments, infrastructure, applications, as well as data. Teleport server access lets you SSH securely into Linux servers and smart devices with a complete audit trail. Teleport Kubernetes access lets you access Kubernetes clusters securely with complete visibility to access and behavior. And finally, Teleport application access lets you access web apps running behind NAT and firewalls with security and compliance. Try Teleport today in the cloud, self-hosted, or open source. Head to goteleport.com to learn more and get started. Again, goteleport.com.
Let's do it. It's go time.
Welcome to Go Time, your source for diverse discussions from around the Go community. Follow Go Time on Twitter and keep up with the polling to find out which unpopular opinions are actually unpopular and which ones aren't. We are at Go Time FM. Okay, let's talk testing. Here we go.
Welcome to Go Time. Today we are going to be talking about testing. We've done episodes before about testing, but testing is hard and there are many open questions, so we thought we would revisit the topic. I am very excited to be joined by a wonderful panelist, some regulars and a new guest who I will be introducing shortly. So welcome everyone. We have the wonderful Chris. Hi, how are you?
Hello. I'm doing well. How are you?
I'm very well. I'm very apprehensively excited about hosting this episode, but I thought it'd be fine because, we're just, swapping Matt out with me and we'll see if anyone can tell the difference. Speaking of Matt, we have the wonderful Matt Ryer, who is turning into a panelist today. In terms of this episode, he is the co-creator of Testify, writes TDD Go, and has recently launched a package called Is, which is like Testify off steroids, and Mock, an interface subbing code generation tool. Hello, Matt.
Hello.
How are you?
I'm good. I'm very excited.
I'm very happy to hear that.
Because I don't have any responsibility.
You don't have any responsibility? No, I have all the responsibility.
It's all on you today, so if it goes wrong.
Great, exciting.
Yeah.
And then finally, we have John Sabados, who is a senior software engineer at the New York Times and a fan of test-driven development. So hi, John.
Hi, good to be here.
Do you want to give our lovely listeners a little bit more about you? Do you want to give a little intro?
I am a fairly recent Go convert, come from the land of Java, but been slinging Go for, coming up on 2-3 years now. That's kind of me. You might also see my cat make an appearance here since he's very helpful like that.
Well, we're very, very happy to have you on the show. I'm extra excited given that, side note, John is actually on my team. So he gets to listen to me be overexcited all the time. So we're going to dive right in, and I'd love to hear from any of you a time that you regret not having testing in place and when it really kind of bite you in the butt.
So there was this one time back at a prior company where we did a lot of financial transactions, and we had routines for doing rebills. And at some point, some change got introduced that caused a null pointer exception. So it was a production defect, and everybody rushed to fix the issue immediately. During the fix, the assignment of a variable got dropped. We computed tax properly without an NPE, but then never actually recorded that result and failed to charge tax on rebills for like a month, which if we had had a proper test in place, that would have been good. Because multiple people were scared for their job when we discovered that.
Matt, Chris?
When money's involved, you really want to have the safety net of tests, don't you? I've had lots of situations, never that's impacted billing, but lots of situations where I'm so supremely confident in a little tweak I just make, and then I just push it, then break something. And it's always a big surprise. And that's the thing I like about testing is it stops you being surprised so often. But I've been kind of obsessed with testing for ages. So if anything, I've gone the other way of over-testing, and I'm sure we'll talk a bit about that.
What about you, Chris? Any testing nightmares? Any horror stories?
I think I'm kind of in the same boat as Matt, where it's more been over-testing that's been my problem. Or I guess the only time I've really been upset about not having tests is when I've written something and then needed to write tests, and I waited too long, and now I have to spend 3 days writing tests, and it's just super miserable because no one really liked writing test code. So I think that's the times I've most regretted not having testing is when it's now my job to go write a bunch of tests.
For sure. I mean, honestly, so I have a kind of a starter question for people who are more my level, kind of newbies. Baseline, why is testing important? Because honestly, I was pottering through Go, writing these mini applications, loving it. And my way of testing was just let me run my app. Does it work? Great. Yes. Awesome. So why is testing important?
Yeah, you can manually test things, but that takes time. And every time, you develop new features and whatnot, do you want to have to go through and do all the regressions for all the various previous tests that you've had in place? Or would it be nice to be able to have automated tests that cover a lot of bases of those things? And that's never going to be complete. And I'm not going to say that you don't ever have to do manual testing because that's important as well. But it helps there. Now, personally, I also find value in testing outside of just assuring that the code's going to work, because you do have to write code in a certain way in order for it to be testable. And I've found that when you start with your tests from the get-go, it makes it a lot harder to write convoluted code that mixes responsibilities and does a bunch of different things. It makes it harder to test. So a nice side benefit from writing testable code is you generally end up with more well-organized code that does a single thing and does it well.
Yeah, I find the same thing to be true. And you hear people talk about test-driven development, and one of the arguments against it is that it changes the way you write your programs. And in my experience, that just isn't the case. It does change it, but usually in a good way, usually in a way that you kind of appreciate later. But for me, yeah, the point is you get to kind of declare what your program is expected to do, and then you can run that automatically. But there's so many benefits. When you're looking at a package, you're going to import a package. If it's got good test code, you can see how you're supposed to use that package from the test code. So the test code is really the first user of that code, that your program. So you're putting yourself in the mind of the user. And I think as software developers, anytime you can do that, you're going to have good results. It's a good thing to do because ultimately we're writing our programs for somebody to use. And it might be ourselves, it might be other people in the team, but putting yourself in the mind of the user is just kind of pays dividends all the time. It's a great way to think about what you're doing, I think.
From my perspective, it doesn't really make sense to me to build something and then not make sure that it does what you want it to do. That seems really silly. It's I'm just going to go build something and I don't know, it doesn't work, but that's okay. We don't need to know if it works. And I guess I see testing on a few different levels. I think it definitely does. It can help you with your design, but I think I've definitely found that it only really works well for that in specific types of circumstances. I know what I'm going to build. I've gotten into messes where it's I wrote too much test code when I didn't know what I was trying to build, and now I have all this test code I have to wrangle with. So I think it can definitely be a sort of double-edged sword in a lot of ways. So I think it's really fundamentally, it's like about making sure that what you write is what you wanted to write and what you implemented is what you wanted to implement. I have this kind of saying that more relates to design than it relates to testing, but I think it kind of falls together that like if you haven't said what it is you're trying to do, then your application is all bugs. You don't have features because bugs are like things that you didn't expect to happen. And if you haven't declared what you expect to happen, then everything is stuff you didn't expect to happen.
Declaring what you want to have happen, apart from just, declaring what you want to have happen, it also helps document the code. Because I can't count the number of times that I've gone into an old legacy piece of code and I've been refactoring or whatever, adding something, and you come across a thing and you're like, wait, is this really doing what the original author intended? What is the intent behind this code? Because it looks broken to me, but maybe it's right. If there had been a test there asserting that behavior, at least you know it's intentional.
I mean, I'm interested to hear a little bit about kind of the process of when you're writing a program. Like, do you concurrently write like a little bit of your code and then write, tests for it? Like, how do you think through how to write tests along with your actual, main application?
Well, when Chris was talking then about sometimes, depending on the kind of problem, sometimes you can't write the tests because you don't really know enough about it. And there are definitely times like that when it's completely new and you really have to kind of knock some things together first to get a sense of what you're doing. But I actually find writing tests can help with that process too. And so I tend to do a lot of TDD. Wherever it's appropriate, I will write the test code first. And usually I'll just imagine, like, I know the kind of problem I want to solve. So I just imagine it exists and I start to write code that uses it. And of course, it's just errors everywhere because nothing's implemented. But that then gives me a kind of to-do list. You know what I mean? So I have my test code. It's broken, usually with errors first. So I just try and make those errors pass. Usually it's like, oh, this function doesn't exist or this type is not there. So I'll just go and add the type. And I try not to jump too far ahead when it comes to putting the program code in. I try and wait for the tests to guide me there because that red-green, they call it red-green testing because you want to see the test fail first. And then you know that you're saying something about your program. And then when you make it green, when you make the test pass, you know that you've then progressed your system in the right way. But I do find that TDD helps depending on the kind of problem. But if I was going to write a package that was going to parse some text and produce some output and some data, then absolutely I would start with a unit test and looking at it from that user's point of view. And in Go, if you put your test code in an outside package, you can put it into, like, if you've got a main program, you can have main test can be the package for your test code. In normal Go programs, it's an error if you have multiple packages in one folder. But with test code, it's okay. And that then allows you to call your code really as though you are an actual user of it. And so you even include the package name in your test code. And what that does is lets you see the API very early. So you can see the kind of API you're building or designing or that's emerging. And that's a nice way to make sure that even just like naming things makes sense and other things like that. Having the test code can really guide that towards good design.
I think I'd say I'm in a fairly similar boat. Like if I'm doing something where I'd call it more of a lab situation where I have no idea, like I'm working with a new service from AWS or GCP or something. Yeah, I'm not going to write tests there because I have no idea what I'm doing. I'm going to write my code and figure out how I'm going to do it first. But then, yeah, if I'm fixing a bug in existing code, a test is going to be to duplicate the bug is going to be the first way that I do it. It makes it easy to solve. I can just run the test repeatedly instead of firing up the application. And also, if I'm modifying existing code without tests, writing tests for the existing code gives me confidence that I haven't broken those existing things. If I'm doing greenfield, then yeah, ideally, I'm going to start out with writing tests as well. Because I have found for me, when I do that, I'll write out all my various different test cases, think through them and think through the scenarios I need to address. It gives me a blueprint. I almost turn off my brain when I'm doing the implementation of the code and I'm just fulfilling what the test needs.
How far do you write tests then? Do you tend to write a lot of test code before you get started on your program code?
It can depend. It depends on what I'm doing. Usually, I'm very rarely standing up an entire new project greenfield because usually, just adding new things. So usually I have a fairly constrained problem set that I'm dealing with. And what I'll probably do is I'll oftentimes think through what's going to need to happen, and I'll build out stubs for, do X, do Y, and the various different things. And then I will attack one section at a time and write the tests and complete the implementation for a piece. And of course, there's, as you go along, you might see, oh, this piece actually interacts differently, so I'm going to have to go back and test, go back and tweak some things. And it does add a little bit of churning time with I've got to adjust the tests that I've written before. But for me, it's worth the trade-off because there isn't that massive, I've been in a hole for 3 days writing code, and now I've got to write test code for a week, because that's never fun.
Yeah. Writing test code is to something that already exists is soul destroying, isn't it?
Yeah.
I have to say that I think I fall on a different side of things than you, John, and Matt. From the way I tend to approach things, I'm much more of a top-down kind of designer than a bottom-up. So I find writing tests is usually too granular for what I'm trying to do, which is why I basically never do test-driven development. Still write tests. Don't use that as an excuse not to write tests. Tests are important. But I definitely find the way that my brain works, it's much easier for me to hold the high level things in place and start sketching them out. And I've just found that that's super incompatible with test-driven development, and it usually leads me to write way too many specific tests than just immediately become debt that I have to kind of deal with. They become garbage in my code base that I have to kind of toss out eventually. And I also think that the style of test that you write really depends on the type of thing that you're writing. I think kind of in a lot of these conversations too often, we take this perspective as if there's one proper way to test and you should use it for all of the code you write. But I have found that, especially for things that are services, like microservices, that I much prefer a model of testing where I kind of write the test, not just underscore test package, but their actual separate package that's this is the test that's going to test through this API, and everything is not just external from the Go API perspective, but external from the process perspective. So it's using the same avenues that all of the requests are going to come through. And I found that this does a couple things. It enables me to separate out the serialization, logic, and storage components without having to duplicate all of the test code between them. And it has also helped me eliminate a lot of dead logic that I'm I think I probably need this. And if you just kind of write tests around it, then you'll see that as covered and you'll be oh, okay, this is good. But if it's dead logic within your service, then you should probably get rid of it. And if you need it later, you can dig it out of Git or just rewrite it when you need it. So I've found that really helps me write much more concise and compact services while also, making my test code look pretty good, because when it's a separate package, you have, all of the linters and things that yell at you if you write gross test code.
Yeah, that's a good point you make. Whenever there's a time, and you see this in testing a lot, where devs have such strong disagreements about things, whenever that happens, it's a sign that it really does depend on the sort of thing you're doing. If you're writing a Go package to do something, I think that's a very different proposition to writing a new service that's going to integrate with lots of other different services. And similarly, all the way up to the UI, when you've got a UI there, having tests in UI code is also a kind of entirely different beast. So yeah, I think I agree that your testing should change depending on what you're doing, that you can't learn just a single blueprint of testing and apply it to everything. I'd even extend that to per project. Depending on the project, even if it's very similar to another project, the testing needs are probably going to be different. So testing is really a skill and a somewhat almost like an art form that you kind of have to learn and apply it to give you that sort of confidence that you need, that your program is doing what you want it to do.
This episode is brought to you by LaunchDarkly, feature management for the modern enterprise, power experimentation in production. Here's how it works. LaunchDarkly enables development and operation teams to deploy code at any time, even if a feature isn't ready to be released to users. Wrapping code with feature flags gives you the safety to test new features and infrastructure in your production environments without impacting the wrong end users. When you're ready to release, more widely simply update the feature flag and the changes are made instantaneously by the real-time streaming architecture. Eliminate risk, deliver value. Get started for free today at launchdarkly.com. Again, launchdarkly.com.
I would love it if maybe you could chat a little bit, for those who aren't maybe aware, about Testify. What is it? How did it come about? Give us that intro for those who may not be as familiar.
Yeah, so Testify, way back in the beginning, one of the things about Go I think is great is that testing is a first-class concern. Ruby on Rails had this too, where testing was just something that already existed within the programs that you were writing. It was kind of there from the beginning. A lot of other languages, testing came later. You know, you have other frameworks or things that you then use. So the Go standard library comes with testing. The Go tooling has support for tests. It knows what tests are and expects you to write them and things. And so when I came from a kind of Ruby and a C# world where I was very used to this pattern of making assertions. So just like saying, okay, I'm going to call this method. It's a greeter. I'm going to pass in my name and I'm going to make an assertion that what comes out of that says, hello, Matt. And if it doesn't, that's then a failed test. And you can do that in the standard library. And what you do is you just write normal Go code. So you'll just call the method and check the result. And if it's not right, you then use a special error F method on that T that you get in Go, the T that gets passed in from the testing package. And then you can fail that test. And it was just too much repeating myself at the time when in the beginning. And so we wanted to be able to just write single line assertions and have the tests just fail in that way. So it's really just a kind of style thing, really. And it didn't exist. No one had made that before. So me and a few friends just made this little package called Testify. And, you know, it was just kind of like, I think it was just around from very early. So it became the de facto way to do it. It's massive, actually. Like loads of people use Testify. And I don't now.
You don't?
No.
What do you use?
I use now that is one.
Okay.
It's a much smaller one. The thing about Testify is one of the patterns for the open source thing was if somebody made a contribution, then they were just added as a contributor to the project. Mm-hmm. This was an idea that was a bit popular at the time, a bit trendy. So anybody that needed to assert some things, like I want to assert that this slice of string contains a particular value, or I need to assert that this value is within an average, within a range of values, and all this sort of things. The kind of floodgates were open to some extent, and they all got added. And if you look at Testify today, it's a massive API footprint. It just has kind of everything. The nice thing is it all works really well because it's been used a lot and tested a lot. But I just found it was too big. Even I couldn't really figure out what I would need to use. And I ended up just using 2 or 3 of them. And so that is project is basically taking just the few. It's like a really minimalist version of Testify. But it's really the same thing. Gives you single line assertions. That's it. So I tend to do that. Or if it's a simpler package, I may just use the standard library, you know, if it's suitable. One of the other things that with the standard library is when it fails, you have to kind of provide an error message and include the values and things. That's where it gets a little bit repetitive because you're saying, I expected this, but I got this. That's what you care about when a test fails. And so these packages let you just pass in the 2 values and it will print out if there's a failure. So that's really all it's doing to help. But there are some people, Francesc Campoy's classic, has a go at me for Testify all the time. He really doesn't like these assertion patterns and stuff. So,
how about Chris, John? Do you use Testify?
Yeah, when I first started into Go, somebody pointed at me at Testify, and actually the whole team, because we have a bunch of Java developers, and we're like, Testify, this looks like the way we should do assertions. And so started out using it. And then when I've actually came time to do manual assertions with Go and the API pragmatically, it's like, what? This is miserable, especially like doing deep equalities on objects. And like if you're testing marshalling and whatnot, and there's a million different things you want to compare and seeing the difference, doing that by hand is terrible. So having Testify, where it gives you a nice printout, it shows you the diff of what fields are wrong and whatnot, is wonderful to me.
I already know this isn't going to go well for me, this one.
Go on. I definitely kind of sit on the side of the fence with Francesc.
Yeah.
I think it's like I watched a talk from years ago by Blake Miserani where he kind of went on this journey of like why you don't really need assertions in a Go. And that kind of like fit with the kind of mentality I already had going forward with like how I wanted to write tests. I was very much in the just do a kind of simple assertion with your code. I do feel the pain of the reflect package and using reflect.deep. Like that's absolute garbage. It just does not compare things in the way that you want them compared. But I think like the Go CMP package makes up for that in some really, really strong ways. What that's kind of like if I have something advanced that I need to get the equality for, I typically lean on that because it is very small and concise and really just does one thing and does it well. And I've also kind of seen that like back when I used to use a lot more assertions, I kind of wrote worse test code because it was so easy to just like throw some things in and assert. And I wasn't really thinking of why is this painful for me to assert? Like, am I writing this like in a way that, you know, makes it difficult to actually compare these values? Do I perhaps need some sort of method on my types that allows me to compare them with ease? Is that comparison something users might want? And should this not just be in my test package, but should actually be part of my API so that users can do this as well? And so I think like once I started also thinking down that path, it made even less sense to kind of lean on Testify and similar libraries. And I definitely agree that Testify's API is just like way too huge. And I think like there was this thing with a lot of the testing packages where they would mess with the output of GoTest, which messed with, you know, people that were trying to parse and kind of process the output. I think a lot of that has been resolved, but it was definitely a problem for a little bit. So I think I fall on the side of like wanting smaller, more direct tools like the compare library that kind of satisfy the needs I have and the kind of sticking to kind of as bare bones as possible. But I also realize that like that's a lot to ask of someone that's new to Go. So I think it's like perfectly fine if you're like new to the language and you're like, I'm so used to having assertions and I'm overwhelmed with all this other stuff I'm learning. Like, please go use Testify or whatever it is that you need to like write test, because it's more important that you write tests and don't get super frustrated and leave Go than it is for you to like be writing, you know, pristine, beautiful test code. Just like write tests, test your stuff, do what works for you, but try to evolve that perspective as time goes on. Don't just be like, well, I've always used assertions, so I should keep using assertions. It's like, I don't know, question that sometime. See how you feel. Feel the same way? Okay, continue using it. But I think over time, you'll probably find that you feel a bit differently.
Yeah, it's really interesting. This was back in like 2013, 2014, where I was seeing a lot of people complaining about the lack of just being able to make simple assertions. And so they were not testing code. There were projects they were just like, well, it's broken, you know, it's incomplete. So we're going to wait for it to be complete and then we're going to add tests. And there were people making the case, you know, and I think, Chris, you nailed it really. Whatever you can do to have your code tested, whatever you need to do is okay. Like, the important thing is having tested code. That really is important. And so yeah, I am very like flexible with anyone's approach to that, whatever that means to them. So yeah, I think testing's the important bit. Which package you use or how you do that, I don't mind. And probably is different, again, depending on all the things we talked about.
Chris, you kind of and Matt, you touched on this a little bit, but I would be interested to hear, how is testing and the way you go about it different in Go as opposed to other languages? I.e., someone like myself, like I've only lived in the Go world. Like, so I'm learning testing from, you know, zero. But for people coming from other languages into Go and wanting to start testing, how is it different? What are the kind of, I guess, tips you can give for people new to the language, but who have maybe heavily tested prior?
Testing is part of the language built in, which is nice. In most other languages, you're using some other random framework. It's hard to say direct comparison without saying, what language you're talking about. Because, if you're coming from Scala land, you're doing some sort of like BDD driven. It's been forever since I worked in Scala, but they had their own little framework outside of like JUnit. JUnit's very similar in some ways to GoTest, where you define test cases and there's no like magic. But then there's a ton of different testing frameworks out there, and they're all kind of different. So I don't know if you can really just say from another language. You'd have to say from a specific language.
Okay.
Yeah, but in my experience, the principles are all basically the same. You're calling your code and making somehow, some statements, some tests about the response you get from some code that you call. And that's, I think it's quite interesting to see the different styles of that. BDD, Judd mentioned, where is kind of you get to write these like sentences. You almost like it's like writing test code in prose almost. And so when you see failures, it's very kind of expressive, explaining what's gone wrong and things. And to me, it's all kind of like they're just sort of different styles of it. But essentially, being able to automatically run a test suite against your code, whatever that looks like, that's really the valuable bit. But I find them to be very similar. I mean, in C#, in Ruby, they had the assertions like Testify has. In that case, it was very, very similar. I think with experience, I've changed the way I think about testing over time. That's more different. And so even years ago in Go code, the test code that I would have written then is probably very different to the test code I've written now. So there's probably more difference with me over time than between languages.
I would agree with that too. Like, I've been writing Go for a long time as my primary language, so it's been a long time since I came from another language to Go, but I've definitely seen very large change in the way that I approach testing as I've written more and more Go and as I've read more and more Go. I think kind of early on, I was very focused on on the low level. I'm just like, okay, I wrote this function, let's test every single bit about it. And then let's move to the next function, test every single bit about it. And then I'd still wind up with some pretty brittle code and some pretty awful designs. And I think that's the initial thing that kind of disillusioned me to writing so much, just writing so much test code and writing test code first. I guess I was trying to make it a design process. And I feel like this is sort of what happens a lot for a lot of people, is that we kind of sub out a design process with testing. And testing is a very poor method of designing software, I think. I think it can be useful as part of the design process, but if it's the main thing that you're doing for the design, unless you understand really well what you're trying to build, it winds up leading you to having a lot of code that then becomes more difficult to get rid of. And I think early on, it's pretty easy. It's okay, well, I don't have a lot of tests, I don't have a lot of code, so changing things is pretty easy. But I think when you're embarking on a larger project, if you don't do that design work up front, you wind up with bugs in your design that you wind up reinforcing with test code. So now you have this behemoth of code that you're then trying to go through and trying to wade through and be I want to change this design now. And if I'd sat down and kind of thought through this a little bit more, I probably would have designed it this way in the first place. But I was trying to get this thing out the door and trying to write all the tests for it and do all of the other things and all of these kind of ceremonies that we have. And now I've wound up in this kind of rough spot. So I'm definitely not saying we should write less test code, but I'm definitely saying that we should see testing as part of the larger process of design and make sure that we are testing our designs, which is related but different. Testing your design is definitely more of a mental exercise of kind of looking at it and being does this actually make sense? So yeah, I think that's kind of where I stand on that.
Yeah, I used to over-test. So over-testing for me is where I've done a lot of work writing my test code to make sure that it describes in every detail what my program code is. Because at that point in time, my program code is working and I want to make sure it stays working. But the problem is, Chris, you mentioned brittle tests, and this is really interesting. So if every time you make a change in your program code, it breaks tests, that isn't necessarily a good thing. That can be a sign that you've over-tested, because, you really want to be testing the behavior of your code, not really exactly how it's doing everything. And so that is kind of tricky. But one example is if I have some code which is going to parse a string and turn that into a data structure so that I can then go on and use that in some other way, I want to make sure that I pass the string in and I get the certain things out. If inside my function, I happen to be using something on disk to kind of keep a cache, maybe a dictionary on disk or something, that's an implementation detail that may not matter to this particular test. And so you would, of course, if that is part of your program, you would want tests to cover that in some way. But if you describe in every point that you're using this function, if you describe the exact I/O operations that are going on and you're making assertions about it, if you then decide to change that, and in fact, maybe we store this in memory now because it's more efficient or something, your test code is kind of bound to that program code's implementation. And you then have a lot of work potentially to do to go and that's when tests start to feel like a burden, that, you know, maintaining this test suite that is just fighting you all the time. Whereas if you can take a view that, okay, some of these implementation details aren't important really to this particular test, so I'm going to just test what's important, and that what's important is a difficult thing to come to, then you're free to change the implementation and the tests just they're happy. They're like, yeah, you've changed it. Sure, you've made loads of changes, but actually all the promises are still kept. So no probs.
So I think this is somewhere where I actually find myself potentially at odds with the Go community in general when it comes to testing. Because if I had something like that where I've got, the system that deals with a potential cache, the way that I would address that is I would abstract that cache out to its own thing and inject it in. And so the code dealing with the cache would have no idea how the cache operates, and it would just trust the contract to that. And I would test it with a mock, because who cares how it's going to the cache? It's just writing to a cache and reading from a cache. That cache can have its own tests, and that keeps that implementation divorced from that. But that is very much at odds with the don't rely on mocks and whatnot that you see evangelized quite a bit within Go.
Yeah, I mean, I will mock code. I mean, mocking is a thing. This is another time where I feel like it depends really matters here. Because I will mock code in certain situations. You want to make sure something is happening. Mock helps you do that. But you are tying that test code to the implementation detail of that. Maybe that's okay in each case. But, what they say is like end-to-end testing as an alternative to doing that is nice. So a bit like how Chris mentioned, he will have almost an external process. So, and we did this too in our PACE project, where our test code would spin up the server using the exec command. So it literally spins up the process, and then that's going to listen to a port, and then it makes calls through the API using the client also that I expect users to use. So in a way, that's nice because your test code is also using the actual client that you want other people to use too. So he sort of validates that at the same time. And then you may, if it's a caching situation, you may make the request, wait a bit, and then what do? You make another request and it's the same, and then you might change something, you know what I mean? Like it gets really strange when you're testing things like that. In that case you mentioned, John, where there's a cache, I think it is quite reasonable to make the case that you'd want to stub that cache out and just make sure that your program code is using it. It doesn't matter really, like you're not testing that cache in this case. It is tough.
Yeah, because like those end-to-end tests are great when they work, because it solves a lot. You don't have to worry about the internals and you have absolute confidence in it. Well, especially at the problem space that we work in, where we don't really care about the output from a thing because we're doing a bunch of things behind the scenes and like sending push notifications and emails and whatnot. And we really care about those interactions that happen with those external entities. And they're very complex and hard to like stand up mock servers for. And that's where I find like the direct unit tests on like this section of code needs to do this thing. And if it fails, it's going to retry like this and back off like this, because that matters with API rate limiting and yada, yada, yada.
I mean, honestly, I'd be with you on that one. In that case, I think, yeah, if what you're building sends emails and it matters to you that this code ultimately sends an email, you don't really want to be sending emails every time someone runs your test code, unless, perhaps you've got an enemy and you pop there with an address in, I don't know. Then it's reasonable, yeah.
So I guess like up front, I generally dislike mocking. I think in the case we've been talking about, I think it's okay, but I also think it's at least to me, seems like a big design problem with the way that we currently have things operating, right? Like I definitely dislike when we have to basically not talk to real things because those things are built in a way where it's not practical to talk to them. Like that's us taking on responsibility for something that we're not really in control of, which I always think is like a little bit dangerous. But I think the big thing I dislike when it comes to mocking is that people try to do it for things that they do control. And it gets people in a habit of doing it for things they control. And then they do it poorly. Like I think whenever I see something using SQL mock, and I've been guilty of this before too, of just like writing garbage SQL that doesn't actually work. But then you're like, you've been unit testing and it's like all working. Then you go to use an actual database and you're like, oh crap, none of this actually works. The reaction that I think would be like, oh, well, that's just a bad habit. You shouldn't do it. But that's a discipline that you have to build. That is mental energy that you are expending to remember, like, okay, when I'm doing it this way, I have to remember to not accidentally write bad SQL, or I have to remember to like test it in this right way. Like that's extra energy that you're expending. And I've just never really found that energy is like worth it to expense in that place. So I think like mocks are a useful tool when you need them, but I'd much prefer, like in the example we're talking about, that like the email service provider has a sandbox, or if it is a big enough thing where this is crucial to what we're doing, that we have a proxy or an API of some sort that we have internally that all of the other different components can talk to, and we make sure that there's a sandbox mode for that, and then it kind of acts as the gateway to the outside world. So then at least when we're doing the mocking, it's kind of sectioned off to one little thing. And I kind of feel like we should spend more time trying to design those types of systems, because I feel like in the long term, it winds up with us having, once again, like less brittle testing. So I also think like, if you mock something and then the implementation changes, your unit tests aren't going to catch that. And then it's like, okay, well, I have my integration test to catch that, or my end-to-end test to catch that. And then I come back around to like, well, if you're going to use your integration test to catch that, why can't you just use your integration test all the time? So it's kind of like this catch-22 and this like road you're kind of navigating and trying to figure, okay, like how often do I need to run my end-to-end integration test, and how much can I rely on my unit test? And that's like a lot of energy that we're expending. It makes sense in a lot of circumstances, but I think we have to think through it a little bit more, and it shouldn't be like our go-to thing. Like I see far too often people are like, of course I need to mock this thing that I'm using. We're going to use Go mock. We're going to generate the mocks. That's what we're going to do. And I also think that leads to kind of hyper abstraction, where we start abstracting a lot of things and shoving interfaces all over the place so that we can have these mocks. And then they're extremely leaky abstractions, and they're kind of gross and difficult to deal with, and they add a lot of indirection to your code, so it's harder to read, and that comes with a whole host of problems. So I think it's a lot like channels and some other things that we brought up on the show before that are like, use these sparingly and understand all of the implications of using them. I feel like mocks and interfaces definitely fall into that, as well as abstractions. And I feel like your default mode of thinking shouldn't be to run and go create an abstraction, because the best abstractions that we have, especially in Go, are ones that have been very thoroughly thought through and changed very, very infrequently. Like I think the IO package has some really great abstractions that are true abstractions. Like you don't care what's on the other side of it. You're not going to think about the implementation details. Those don't matter to you. And I think a lot of the time we wind up creating abstractions that are not at all like that, that you dig in and you go grasp that implementation detail because it makes your life easier, or because you just can. So I think like we should avoid abstracting until like we actually need it. But once again, if you're new to Go and you're like, this is easier for me, it requires less mental energy for me to use mocks and to do it this way, I'd say write the code and learn as you go. Obviously work with your team if you're on a team of a bunch of like more senior Go engineers and they're like, we're not doing mocks. Well, that's going to be a little rough for you. But I think if you're just kind of learning things and you're like, mocking makes it easier for me to understand these other concepts I'm trying to learn, go use mocking. This isn't like a no, thou shalt not mock. But I think we should really consider how much effort it really does take at the end of the day to use these things. So I think often we just assume that they don't take much effort at all.
Yeah, the thing is, when you find an abstraction, the best abstractions for me emerge from when I've solved the problem a few times. Then an abstraction might emerge from that. And when it does, especially if it's a tiny little single method interface or something like we see in the standard library, it's such a good feeling that you get sort of addicted to that, which is why I think we start there, because that's what we want. We want these abstractions to exist because it unlocks so much power. You can plug anything into this if in a good abstraction. The trouble is, they are hard to find. They're hard to get right. And so I'm with you, Chris. Me and David, I work a lot with David Hernandez. We even have reached the point where we won't do any abstractions until it's too painful for us to carry on. So that usually means having the same thing copied and pasted 3 or 4 times. And only then is it like, we can't fight this anymore. There is an abstraction here that's worth then going and retrofitting. And our code generally is better for it, for resisting those abstractions. Another thing on test code that I'll say is, it's a principle that I've found, which, John, you mentioned this earlier, is to really only test your code. Only test one thing, like if you can, in a unit test. Like, here's an example. If you're going to unmarshal some JSON, you're probably going to use the standard library's JSON package or one of the other JSON packages to do the unmarshalling. It's not your responsibility to test that thing. You know what I mean? So I used to in the past, and this is a mistake I've made a lot, I would have some object and I would unmarshal it, and then I would have an assertion for every field that was unmarshaled. And that kind of gives me the confidence that this is working. Now, really what I'm doing there is testing the JSON unmarshaller and marshaller. I'm not really testing my code, which just uses that. And so, I'll tend to now, I'll have a slightly more relaxed attitude to it. I'll test a field to make sure that it worked, and then I can sort of trust that it works. That has bitten me before, where one of the names was wrong in the JSON thing, but it doesn't happen very often. But when that then did happen, then I added more tests to that. You can't really have strong rules that you can just always follow. But I do find being a bit more relaxed about testing still gives me enough confidence so that I can sleep at night without it being me basically just repeating my program code. It's tough though, isn't it?
Makes sense. Yeah, well, and it can be difficult. So like using marshalling as an example, an incident where the output format from our things very much so mattered, and it actually mattered with the Go tags because, yeah, we knew that we could marshal stuff correctly, but if there was a field that had omit empty on it, it would actually break the Android readers of stuff because in other languages, an empty set is not, or an empty list is very different from a null list. And so it was actually really important that we have this automation on our output contract that asserts this is our output. Yeah, we're kind of testing the JSON marshalling, but really that's not what we're testing. We're testing that we actually had the annotation. Well, we're testing that the rendering was correct, and it doesn't matter how it was done, but just that a response marshaller gets there. But yes, you can see, yeah, we don't necessarily need to do that for everything. We've got to find the right scenarios. I think where I find the end-to-end testing that was specifically using SQL as an example gets hard is in failure scenarios. And so again, and maybe this comes from working just in environments that I've worked in, where one company was working with virtual cell phone carriers, so you're integrating with Sprint and whatnot. But like where you're writing with multiple different data stores, participations and transactions, and like when to roll a transaction back might be very important. While simulating those failures with a local DB, that's impossible to do when you're actually talking. Well, I shouldn't say impossible, but incredibly challenging to do. So again, I guess those are the scenarios I run into where, yeah, it's very painful that the Go SQL library can't be mocked because I want to make sure that this transaction gets rolled back when this other write fails. But I can't really do that with the stock library.
I feel like with SQL, though, that's a good example where like we do have a really good abstraction. So it's like, you can just write a fake driver and you're like, okay, I'm going to use this driver to test a specific scenario, and it enacts that scenario quite easily. And I kind of see that a little differently than like generic mocking, because you're not actually really changing the implementation that you're handing the code in a way that it needs to care about. What the code needs to care about is like, I'm using the, SQLDB and SQLTX and all of the stuff to make these queries, and then it goes somewhere, and then I get some result back, and then I do other things. I often hold up the database SQL package as a really good example of how we got the abstracting right in the standard library. And I think oftentimes I'll use an example and people kind of point out to me, they're like, oh, but SQLDB is an interface. I'm like, no, it's not. It's a struct type. The driver is the interface, and that's the thing you got to implement. And then it's like you can do what you want with it after that. I think that does require more tooling that we might not really have. It's definitely easier to use SQL mock to do that kind of stuff. But I think also if those types of failure modes are something you really care about, then that's something you should be investing in. And perhaps even investing in a type of database that allows you to do the kinds of failures within the database. I've worked on databases before that have these types of fail points within them where you kind of set it up in a specific way and then you make a query and then boom, it'll fail in a way that you expect it to fail in kind of a certain production scenario. So I think once again, it's like that. A solution is to use mocking, but I think that also is something we can fix with the technologies that we're using and making them get better. And I also realize that that's a huge ask. I don't know, adding failure points to Postgres is probably a giant nightmare. So not something that's really practical, but I think it's something that can help us as a community and as an industry think better about the types of products that we're building. So maybe the next time you're building a product, you can say, well, maybe I should have a way for people to induce failures so they don't necessarily have to mock and they can just use the actual real implementation to get those failures that they want at the time that they want them. Obviously, a lot of extra design costs there. It's not an easy thing to do. It's extremely difficult. But, we don't get paid big bucks because we just do things easy all of the time. We get paid big bucks to solve difficult problems.
I don't get paid anything at the moment.
This episode is brought to you by SourceGraph. SourceGraph is code search for every developer and team. Easily search across all the code that matters to you in your organization. Find example code, explore and read code, debug issues, and so much more. And I talked with Byung Lu, CTO and co-founder of SourceGraph, and asked him to share what code search is, what developers and teams are missing out on, and how SourceGraph provides code search to every developer in the world.
If you've worked inside a Google or a Facebook or any one of these really big, well-respected technology companies, chances are you've used something like code search before, and you know the value that it provides to your team. You know that almost every single engineer inside these organizations uses it on a daily basis. If you've never had that experience, chances are you may not know what you're missing out on. The term code search sounds a lot like, grep or the search inside your editor. And that's what a lot of people think when they first hear it. But it's really about much more than that. It's really about connecting you as a developer to the broader universe of code and code-related data that's relevant to you, that you need at hand in order to enter that, magical flow state of, being in your editor, writing code quickly, making rapid progress towards that feature or bug fix that you're working on. It's really about making all that contextual information accessible at your fingertips. And what that means is think about every single repository, every single file, and every single language, every single diff, and every single open source dependency or maybe closed source dependency that's shared across your organization. All that is searchable through a single text box. And that's really powerful because it means all this friction is eliminated between you and understanding that broader world of code. You don't have to clone stuff down to your local machine. You don't have to mess around with editor config. You don't have to be constantly bugging people on other teams who may not even know who you are in order to teach yourself how all that code works. What SourceGraph is really a way for the rest of us, the people who don't work inside the Googles, the Facebooks, to get a tool that gives us access to that sort of information readily and at our fingertips. It's really about bringing this type of tool that a lot of the larger technology companies have developed and invested hundreds of millions of dollars into making for the productivity of their own engineers and making that accessible to every single developer in the world.
All right, if code search powered by SourceGraph sounds like something you and your team can use, head to info.sourcegraph.com/changelog and click the button that says try SourceGraph now. You can install it locally, deploy it to a server or to a cluster. They have a quick start guide that takes less than 5 minutes to install SourceGraph using Docker, so it's too easy to give it a try. Again, head to info.sourcegraph.com/changelog.
The interesting thing about errors, because that's another thing I think with code coverage, you can measure code coverage and it gives you a percentage. And so whenever you've got a percentage, we want it to be 100%, don't we? Everyone, it's very natural. I think 100% code coverage is not what you should go for in Go specifically. And honestly, I don't test the if error equals nil things unless it's part of my API design. If I have a special kind of error, like a sentinel error, as Dave Cheney coined, that is part of the API. So in this particular case, I get back this error. I will then test those. But if it's program code that's doing things and I have a lot of checks for errors and I return the error in an error case, I'll just maybe test a few of the key error cases. And then I trust myself. I trust that we've done errors properly. That probably won't be appropriate for every case. But I think shooting for kind of 100% coverage means you have to try and get everything to error, like we're talking about, like the OS package. If you're going to open a file, how do you get that to give you an error as part of a test? It doesn't really matter in a way, like if you're handling that error properly. So I tend to omit that from unit tests. Another thing, you can sometimes address these problems with different design too. So one example is idempotency or idempotency. I don't know how you say that. How do you say that, Angelica? You speak very properly.
I say idempotency.
Yeah, I would say idempotency.
Idempotency.
I always try to just type it out. That way I don't have to.
Well, even if you're talking to someone in real life?
Just write it on a Post-it note and hold it up.
Yeah. Even in real life situations, you do that, John. Do you?
Totally.
Yeah. This should be idempotent. Idempotent. I don't know.
Idempotent.
Well, this idea that if you've got something that could go wrong, and if it goes wrong, if it fails, you can then retry it and you're not going to end up in a strange state because no matter how many times you run the code, the idea is you end up in the same place. That as a principle really helps because suddenly your testing can be simpler because you don't have to check if the database might give you an error or the file system might give you an error or the email sending thing's going to give you an error or something. That's hard to make idempotent though. So sometimes I think there are design things you can do. And also I think you can trust yourselves to some extent that you're going to write the code properly. If you don't, then it's kind of obvious, but maybe not. How do you feel about that? Do you want to test all those if error checks?
Generally not. I'll second, shooting for, I would say there is no correct coverage number that you should shoot for. I've actually had things go horribly wrong in the past with developers putting everything on one line to meet coverage requirements. And yeah, no, it's not important to test every single error check. There are conditions where, it is important to have a test to ensure that an error check happens, but that's going to be a case by case basis and determining whether or not it really matters. Should you be testing for the write to the output stream fail? No, that's never going to fail. Or if it is, it's a request that the network connection went wrong, whatever. It's not the end of the world. But, the example that I got today is I get a routine that has to read from one system, read from another, and then if they're different, write to them. Well, so writing through those tests, it might be important to, if the read from one fails, well, yeah, we shouldn't do a write type thing. I usually end up getting to that point where I'm writing those tests, though, because I've written out a string of code and I'm putting in my tests, and I find that building those I haven't done TDD, so I'm building a test on existing code. Well, I've got to build through all these scenarios anyways, and so that just happens by happenstance. It's not so important.
I would go as far as to say that 100% test coverage is impossible if you have any definition that makes sense for test coverage. I think running all of the lines is insufficient for actually understanding if you've covered your code. And then once you start bringing into branching and things like that, if you have even a moderately sized application, it's not really possible to test everything. But I also think test coverage I found to be a really bad heuristic as far as, is your code actually doing what you want it to do? It's just too easy to just I'm running the code and not really testing it for realsies. And I think that's back to where we should be doing design. We should be defining what we mean by these things. Something we're not really good at doing as software engineers, which is kind of ironic because we're pedantic about almost everything. But that's something that goes into design doc of what is our testing plan? What things do we need to test and how do we need to test them? And to do that up front, it's a failure of our industry that we kind of go in. TDD sort of helps with that, but I think it's a failure of industry that we go in and we don't know what we're supposed to do until we've done it. And then we say, oh, look, we did the thing. I don't think TDD is sufficient sufficiently large enough in granularity to kind of handle that situation. And I think what that kind of runs us into is the eternal question of, is this a feature or is this a bug? Well, we don't really know because we didn't define really concretely what our features were up front.
Yeah, so you've mentioned this before, Chris. We differ on this because you have a lot of success, I think, with the design process up front and thinking ahead. And I don't have the same experience. I'm much more effective kind of improvising my way through it and doing it as I go. Obviously, that's just broad strokes. I'm saying that, generally speaking. Sometimes, of course, you can't really beat a good design. But that's an interesting difference. So I think sometimes maybe personality type or something else that may even play into that, like the dynamics of a team and how you think about things. I think that probably comes into this too.
I would suspect that we probably are more in agreement than we think we are, but our semantics are differing. And that's where the difference comes in.
Oh, really?
Because the way I think about kind of upfront design and what kind of goes into a design, I think is very different from what most people conceptualize as like a, what do you do when you write a design document? And I think there's so much nuance that really goes into it. Like, I expect that during a design, you will be writing code. You will be prototyping. This is not like I'm going to sit there and theorize things. It's like, no, you need to write real code. You need to see if your ideas actually work. This is not like I'm going to write a design in the abstract and hope that it works. I think the main thing for me is like, do you ship that code? And the answer is always no. It's prototype code. You do not ship that. You write it again once you understand the space better. And I think that's where TDD can be very, very helpful because now you know what you're writing and what you're doing.
Yeah.
So I think a lot of where we have differences here is likely down to semantics and nuance, which is okay. That's like part of the process of like understanding and evolving ideas is like coming together, having conversations.
Yeah, okay, that's really interesting. I'd love to see a talk if you wouldn't mind doing one at some point and showing your process there because it sounds kind of very interesting. But you're right. I mean, I will often rewrite, I rewrite everything. Like I'll write something once and I do use tests because for me, that really just helps me think about it. But then I will rewrite it. Almost 100% of the stuff I've done is a rewrite because you learn so much in that process. And usually you learn like, oh, all these things I was thinking are unnecessary. You know, hopefully a nice, much simpler design has emerged by the time you've been through that process. And it's actually quite easy to rewrite once you've got something. Because like you say, you know then what it is. And you can usually like copy, there's probably chunks that are great that you keep and you can copy them across. But I do rewrite a lot. That is something that I find myself doing. I find it to be kind of really great. And actually, I get complimented sometimes on, not very often, not often enough, if I'm honest. But I do sometimes get complimented on like API design. And people usually ask that, like, how have you designed that so well? And it's a rewrite. It's like, it's a version 2 already before anyone else has ever seen it.
Angelica?
Yes, I have many views, but I'm honestly, this is the best podcast ever in that I am just sitting and soaking it all in and having the best masterclass of my life. It's brilliant. But we are actually serendipitously going to be turning over and cooling our beans on the wonderful testing fire that is this conversation. And we'll be talking a little bit about your unpopular opinions.
I actually think you should probably leave.
As our wonderful guest, John, I'm probably going to turn over to you first. We would love to hear an unpopular opinion. It does not need to be Go related. It does not need to be testing related. It can be world related. It can be duck related. It can be anything related.
Well, so this will probably make me some enemies, but chocolate's kind of nasty.
Chocolate's nasty? Well, I have one thing to say about that. You mean American chocolate is nasty? Because I'm sorry, but British chocolate's on point.
They're different.
Yeah.
Actually, milk chocolate, like Hershey's milk chocolate. Actually, I don't know if that's even American or whatnot. That's the only chocolate that I like. You know, the stuff that people normally think is good, like the dark chocolates and whatnot. Oh, no.
Okay.
That Hershey's chocolate contains no chocolate. Did you know that?
Okay, that's probably why I like it.
Yeah.
It's pure sugar.
Yeah, I don't know what it is. It's true. American chocolate is weird.
I feel like Easter's just around the corner. What are you going to have for Easter?
I'll still eat Cadbury Easter eggs because, you take the top off that, lick all the goodness out of it, and then you just kind of stomach the chocolate. That's kind of like, the crust around a peanut butter and jelly sandwich. Get that out of the way for the good stuff in the middle.
Well, Cadbury's a whole other situation. I am 100% behind Cadbury. I went to the Cadbury's factory when I was 12, changed my life forever. I am surprised that I am not the size of a whale. The amount of chocolate I eat. Well, I should probably share this on Go Time, but whatever.
Too late.
I had a whole Dairy Milk chocolate bar like that big, like family pack size for breakfast this morning. Just because I fancied it.
That's a shock.
I had my coffee and I had my chocolate bar, and then I rocked up to our team stand-up full of happiness.
Nice.
Wired.
Ready to go.
Yeah. I'm with you on that one, actually, about chocolate generally. But I do like kind of like dark, like fancy, if it's fancy kind of chocolate. Ooh. I couldn't eat a full bar of it for breakfast. That's something else.
Not psychotic. This is not like a regularity. This is like I thought I'd treat myself this morning.
Right. That's a treat.
So I went for it.
How did you feel after it?
Very happy. I mean, I was full of energy. I had a very productive morning. Many a meeting that I got what I needed to get done. And then I had a bit of a crash before go time and been pushing through since. You live a very healthy life, John. I wish I didn't like chocolate.
Just because I don't like chocolate doesn't mean I don't have other vices like, Mountain Dew.
Oh, okay.
Generally, anything super high in sugar, I'm a huge fan of. Like pure hard candy, good stuff. Skittles. Actually, like my favorite candy is actually, what is it? The rock sugar, whatever, where you basically dip a string in sugar water and pull it out and it builds up a crystal of just sugar.
Mm-hmm. I had those things that you got at Halloween that were just like packs of coloured sugar that you had like a dippy thing that you were supposed to dip in it.
Sugar
but I
dip.
used to just like get rid of the dippy thing and just like lick my finger and just...
Nice.
That dippy thing was also sugar, wasn't it?
Yeah.
Yeah.
Yeah. I don't know.
So you had two versions of sugar.
Some fruit is too sweet for me.
Oh, okay.
So I really don't have a sweet tooth.
For me, it's like one of those things where like once I start working out, I have to do running in the summer. I just like can't do as much sugar anymore. Like I stopped craving it because my body's just like, this does not do well for us when we need to like work out the next day. You are miserable. So you're just not going to want to eat any of this like highly sugar stuff. But like when I'm not working out, it's just like, yes, I will eat an entire pint of ice cream in like one sitting. But like now I will like not do that. I'll be like, I'll have a spoonful now and that'll be good. That's it.
That's good, isn't it?
The complete opposite. The chocolate bar was a little bit of a well done because I actually went for like a run. And when I say a run, I mean like 10 minutes on the treadmill. And I got back and I was like, I really burnt some calories this morning.
Yeah,
Chocolate.
I really deserve an entire rectangle of chocolate for that. Wow.
You made me regret telling you all this. I thought we were in a safe space. Chris, do you have an unpopular opinion that you would like to share?
Oh, okay. Sure. Here's a hot take. Ooh, maybe this will actually be unpopular. I'm trying to get an actual unpopular thing. So I think Agile's time is done and over with, and we need to move on.
Wait, so you think we shouldn't do Agile?
Nope. No more Agile. No more Scrum. Move on. No more sprints.
How are we going to stay organized and on track and meet our KPIs and our OKRs? My product management brain is just going to explode.
I'm not saying we have nothing. I'm saying it's time for us to figure out something. I will say that I have never worked on a team where like Scrum specifically, like sprints and story points, never run a team where that functions well. It just never does. And I know it works for some people and I know it works in some very specific circumstances, but I just think in general, it's like we just do wonky things to try and make the process work. And, it's something that, a couple people or a small group of people came up with, 20 years ago. And we should probably kind of evolve the way we do things. So it's like we don't do things in the way that we did them 20 years ago. And I think there's a little bit of an argument too when it gets to what kind of software engineering processes were we using that led to Agile and how we're doing things differently now and how those two things are rather incompatible with each other. But I think the simple thing is just like, let's use that innovation we claim we have so much and innovate toward something new. And please don't use silly analogies anymore. No one trains for anything by sprinting all of the time. You take breaks. Like, if you're an athlete and all you do is like work out all of the time, you will hurt yourself and you will not do well. And I think that fits with software as well. We don't write good software when we don't take breaks. So take breaks. Let's move on from Agile and let's do something new.
All jokes aside, despite my initial visceral reaction, you have a point.
Yeah, see, that's the problem is I keep explaining my unpopular opinions and then they become popular.
I wouldn't classify it as popular in my brain. I would classify it as worth a discussion. Is what I would say.
If you had said we should go to waterfall strictly, that might be unpopular.
That would be.
But
Booted from the show.
Every single team I've been on, it eventually devolves into some form of uncontrolled Kanban with the pretending of sprint ceremonies on top of it. But without the whip limits and everything, they make Kanban work.
Yeah.
Other than on our team, obviously, John. We run it perfectly smoothly and incredibly.
Absolutely.
I think it's, again, a bit like with what we said about testing. The kind of thing you're doing, the dynamics, the people in the team, all of that should influence how you operate. So anytime you try and have a framework that you're going to stick to no matter what, rigidly, and ironically, people do that with Agile, I think you are in trouble. It has to be slightly more flexible. And the other thing that teams need is you need to trust the people in the team. That you can cut out a lot of overhead if you trust the people you're working with. And you can save a lot of time. And sometimes, unfortunately, people don't feel like they do trust the people in the team. And I think, that they've got different problems, probably bigger problems. But yeah, I mean, again, team size, I tend to work in kind of quite small teams. I'm a fan of small teams, and everything's a little bit easier when the team's kind of tiny. So yeah, it probably isn't unpopular with me, that one, Chris. Plus, you do explain it so well. So that, they all become popular. You're just changing minds, when you...
Yeah.
Changing minds through your pure eloquence and explanations.
I keep trying for these unpopular things, and then I do the poll, and it's like 80% popular.
Yeah.
Like, I keep failing. Like, come on.
Awesome. I think we're actually at time. Regrettably, I've absolutely loved chatting to you all. It's been so fun hosting my first Go Time episode. I'm excited to do many more. And thanks again. See you all soon.
Thank you.
Thanks for having me on.
Shout out to Angelica for your first time hosting. Excellent work, my friend. She has another episode coming up. It's called What Makes Wonderful Workshops. Don't forget, we have a back catalog for you to dig through. It lives at gotime.fm. There you'll find our recommended episodes, the most popular listener episodes, and more. Go Time is produced by Jared Santo with music by our Beat Freakin' residents, Breakmaster Cylinder. We are brought to you by awesome sponsors. Special thanks to Fastly, Launch Darkly, and Linode. Next time on Go Time, a special episode, Chris Brando will be delivering his ultimate guide to crafting your GopherCon proposals. Stay tuned for that one. It's coming at you next week.